Welcome to Single Phase Motors Part 2 video. We are discussing about resistance start induction run motor or RSIR motor today. For any single phase motor with only one winding, it is not self-starting, that we know. To make it self-starting, we should be having two windings. The two windings will be having two fluxes at different times like this. If it is a flux wave like this in blue color, it is having a time period, and any other winding, let us say for example for a winding which is shown in red, it is taking a current, and these are having fluxes at two different times. Let us say it is having two different fluxes at different times, or the maximum flux will be happening at different timings. This is known as its phase difference. And because of this phase difference, winding one or the red winding and blue winding, it is having flux different times. Effectively we can see the flux, it is rotating in one direction. In this condition we can say it is in clockwise direction. The flux is moving clockwise. So this is happening when two windings are provided in the stator. The stator is having a revolving magnetic field. The speed of the revolving magnetic field is known as synchronous speed. So a synchronous speed revolving magnetic field is available in the stator. Now what happens to the rotor? The rotor, it is at zero speed or standstill condition. Zero speed or standstill condition. Then what happens? The rotating magnetic field flux cuts the rotor conductors. Okay. The rotor conductor is available here. It is cutting the rotating magnetic field, and EMF will be induced in the rotor. In the rotor, EMF will be induced because of the cutting flux. Clear? Now, what as per Lenz's law? As per Lenz's law, the EMF will oppose the reason producing that. Or in other words, we can say the as per Lenz's law, it will try to reduce the EMF. How to reduce the EMF production? What is the reason producing here? The reason, it is the rotating magnetic field, and the rotor is standstill. Now what happens? The rotor will also try to rotate in the same speed. The rotor also will try to rotate in the same speed of the stator magnetic flux. So that what happens? Effectively, if it is the same speed, effective flux cut will be minimum. At zero speed, the flux cut will be maximum. As the speed of the rotor is increasing, the flux cut will be reduced. So the as per Lenz's law, to reduce the flux cut, the rotor also will try to rotate. Or we can say the motor now starts to rotate. What's the part of the motor starts to rotate? The rotor. The motor will now rotate and try to rotate at the speed of rotating magnetic field. What is the name of rotating magnetic field? It is the synchronous speed. So the rotor try to catch up the synchronous speed, but it will never attain synchronous speed. Why? Because at synchronous speed there will be no induced EMF, because the relative speed between the stator rotating magnetic field and rotor will be zero if the rotor is running at synchronous speed. Hence it will not attain the synchronous speed. The rotor of induction motor will always run behind the synchronous speed. The synchronous speed will be more, and the actual speed or the rotor speed of the motor will be less than the synchronous speed in the induction motor. Okay, so this is the working principle of induction motor, and each split phase induction motor, it is working similarly. Okay, so this is known as split phase induction motor, and we are interested to know how in resistance start induction run motor the difference of phase is made. The difference of phase, the one phase it is like this, and the second phase it is having a difference. So the current and hence the flux is having difference. In RSIR motor, in resistance start induction motor, our question is how this phase difference is created. How the phase difference is created, that is the question. That is done by two windings. One is main winding and second is auxiliary windings. So the auxiliary, how the phase difference is made? The main winding will be having very high inductance. The main winding will be having high inductance, and the auxiliary winding will be having high resistance. Both are having two separate natures. The starting winding or auxiliary winding, it is known as resistive winding, and main winding or running winding, it will be taken as highly inductive winding. L for inductance, highly inductive winding. So this is the method how phase difference is obtained in RSIR motor. RSIR motor. In RSIR motor, the phase difference is because the main winding is highly inductive, starting winding is highly resistive. And additionally, there is a centrifugal switch. What is the function of the centrifugal switch? Actually, the starting winding, it is only in the starting condition to make a starting torque, to give a torque. After the running condition, the starting winding will be cut out. After the starting will be cut out by a centrifugal switch. We will see these all things one by one. Main winding, it is highly inductive. Auxiliary winding is highly resistive in RSIR motor, and the centrifugal, it is normally closed up to 75 rated speed. कम speed है तो ये centrifugal switch open नहीं रहेगा, closed रहेगा, normally closed रहेगा. 75% rated से आगे है तो if the motor speed it is more than 75% speed, the switch will open out. How the centrifugal switch will operate, we'll see. So this is the stator revolving flux around the stator, and because of this, the rotating rotor also will try to rotate because of the interaction. Now this is the physical condition of centrifugal switch, and you can see a hole here. Through the hole, it is mounted onto the shaft. So shaft will be here, and it will be mounted on the shaft. And in the centrifugal switch, you will be able to see the contact. Normally it is closed, and when the speed is more, it will be try to open up due to the centrifugal action. Due to the centrifugal action, the contact here, it is normally closed, but after 75% of the rated speed, what happens? The switches will be opening up. How? It is due to the centrifugal action. What is centrifugal action? You will be able to see this rotating girl, it is moving far away, or it is falling long away because of the centrifugal action. This is known as centrifugal action. Any rotating object will move far away with respect to the speed. The more the speed, more away the fall. Okay. If it is very less speed, the girl would have been fall very nearby, but it is not here. The centrifugal force it is making, it is passing far away due to the speed of the shaft. In our motor's case, what happens? There is a centrifugal switch. Due to the high speed, the contact will be separating away, and that it is used for operation. So we have discussed about the circuit diagram of the RSIR motor with the main winding, with auxiliary winding, their properties, and the centrifugal action, and how the motor rotates. And we will be considering the currents and voltages in the RSIR motor. And you can see this is the line voltage. A small shift is there in the line, or I can draw again. So this is the voltage line of the motor, and there should be a main current. I will put it in blue color. This is the main current. Where is the main current flowing? Main current, it is flowing in this way. Okay. And let us change the color to something else. There is a starting winding current. Starting winding current flows this way, and starting current it is like this. Okay, starting current. So this is starting current vector. So both are having what? Some phase difference with respect to the voltage. You can see a 15-degree phase difference between line voltage and the starting current, and 40-degree difference between line voltage and main current. Effectively, there is a current drawn from the line that will be drawn a separate color. So this is the effective resultant current from the line. The motor is taking I line from the main path. So this is splitting into two. It is motor main winding current and starting winding current. Now, important to say, the phase difference between these two should be maximum. For the maximum torque in the motor, the angle between I main and I start, if it is maximum up to 90%, it is theoretically possible value, it is the high torque. Now, what is the angle between here? What is the angle between these two here? It is 25 degree, that is 40 minus 15. 25 degrees between starting current and main current. It is a very small angle, and the torque of the RSIR motor will be comparatively less. The RSIR motor is having a less starting torque because The difference in the angle between starting winding current and main winding current, it is only 25 degrees. Now we are telling about the torque speed characteristics of split phase induction motor, that is RSIR motor. Speed it is given in 10% and the torque it is given in this way in the y-axis. What you are able to see is at zero speed there is a torque. At zero speed there is some torque, and the speed will increase when switched on. The torque is increasing, the speed is increasing, and it is going in this way. It is reaching the maximum torque. At 75% of the rated speed, what happened? How it is 75% speed? You can see this is almost near to 75% speed. At this area, the centrifugal switch will operate. At this area, centrifugal switch will operate. What happens? Centrifugal switch operated when the centrifugal switch is on, open. When the centrifugal switch is open, only main winding will be available. Only main winding will be available, and the starting winding or the auxiliary winding will be cut out. And that is the reason it is known as starting winding. The winding which will be only available during starting time, and after attaining 75% of the rated speed, it is known as starting winding. So that is the reason the motor itself is known as resistance start induction run. The meaning is it is starting with the resistance winding and it is induction run. Only induction winding will be there during running. The resistance winding will be turned off. Why we are turning off the resistance winding? Why auxiliary winding is having high resistance? Why auxiliary winding is given inductance? What if what would have happened if the starting winding is having inductance and main winding is having resistance? The motor will work, but during the operation the resistance will be there in the running winding. It is giving wastage of power. The power will be wasted as I squared R drop. So to remove any to avoid any losses, we'll be making the starting winding highly resistive and running winding highly inductive. And during running, what winding will be there? Only main winding with highly inductive reactance. And at full load, it will be giving you full load speed, and it is giving the full load torque at full load. Obviously, at the full load, it will be giving you the rated speed and full load torque. And if you are increasing the load further, you can see the torque it is getting reduced at 10% speed. Almost it is getting stalled. It is getting stopped. So this is the running torque characteristics, and to the values we can say at this graph part it is with starting area with both starting winding and running winding will be there, and at this area this is 75% of rated speed. The centrifugal switch will be open up, and after that only running winding will be there during running, and we'll be getting a value of starting torque like almost 170 or 175. 170 or 175% of the rated torque will be available for the resistance start induction run motor. So this is the torque characteristic with numeral. And how to change the direction of rotation of a normal induction motor? Single phase induction motor direction of rotation changes changing by either starting winding or running winding. You will be able to see the picture now. The running winding current it is in this direction, and starting winding direction current it is in this direction, and direction of rotation is clockwise. Now you see the right picture which is changing the current. Only the running winding it is still the same current, same direction, but the connections of the starting winding, you will be able to see the starting winding upper connection has taken to the lower part of the supply, and the lower part of the starting winding it has been taken to the upper part of the supply. So the connections are now interchanged. To the connection interchange, you will be able to see the direction of current now flows in the opposite direction. Okay, so the current in the starting winding is changed. We have to change the direction of current through starting winding. By that, we'll be changing the direction of rotation. So the question is how to change the direction of rotation of a single phase motor. It is by changing the current through the starting or running winding only at once. Okay, you have to change only running winding or starting winding, not both. If you are changing both running winding and starting winding together, the direction of rotation will not change, it will be the same. To understand more clearly, you will be able to see in the left side U1 and Z1 are connected, and U2 Z2 are connected. U1 may be the main winding and Z2 the auxiliary winding. In the second picture, you will be able to see U1 it is now connected to Z2, it is interchanged, and U2 now connected to Z1. So by changing the interconnections of starting winding, we are changing the direction of current through that, and hence the direction of rotation will be changed because the magnetic flux will be changed. The attaining part will be changed, and we'll be summarizing the features like this. Generally, it is less capacity motor up to 0.5 HP, half HP motor. We are using RSIR motor, and it is having very low starting torque because it is having only 25% or 25 degrees between the main and auxiliary winding currents. Phase shift is very less. So it is low starting torque, and it is used for driving the fans, grinders, washing machine, etc. woodworking machines. And one more thing, the bottle coolers in refrigerators. Actually, this motor is requiring no capacitors. It is not requiring any capacitor, so the motor can be totally sealed. The sealed motors are more suitable for refrigeration application to avoid any humidity, and bottle coolers of lower capacity is being used with RSIR motors. And generally for single phase motor up to 3 HP we are using 3 single phase motor. More than that we can generally use 3 phase motors only. But nowadays the 3 phase motors are also developed with half HP or lesser capacity also available with 3 phase, because the 3 phase motors are having very lesser maintenance, and the induction windings are generally prone for damage in the single phase motor, and it is comparatively less for industrial applications. Anyway, want to summarize, for 3 HP and above we will be going only for 3 phase motors, and maybe up to 3 HP we can make single phase motors. If you require still lesser maintenance, even half HP sort of things also 3 phase we use now, because of single phase motors require more maintenance.